Hello friends, this is Guy Manor James. In this video we are going to look at a technique for anti-differentiation. In differential calculus we learn about 4 techniques to differentiate complex functions like product rule, we have quotient rule, chain rule, and all those stuff. In this video we are going to learn one of the 4 techniques that we can use to integrate, which is anti-differentiation, to integrate complex functions like the numbers that you can see on the screen. These numbers are quite complex and simple integration would not do it, so we have to use certain techniques. For example, substitution, where the derivative is present in the integral. This is one of the 4 techniques that we are going to look at. I will also make 3 more videos for the remaining 3 techniques, so be sure to follow those videos and subscribe to my YouTube channel. Click the notification bell so that you can be notified whenever I post a new video. Now let's get started with the first problem. First thing first, you have to recognize where the integrand, whether there is a derivative in the integrand. Now in the first problem we have a derivative in the integrand, a function that we can differentiate. So let's u be x plus 3, and then du out of dx is going to be 1. So dx is just going to be du. Alright, now it's going to be u raised to the power 7 du. So you have to integrate this one at this point. So u raised to the power 8 out of 8 du when you integrate this. Then the final answer is going to be x plus 3 raised to the power 8 out of 8 plus c, because now you have put x plus 3 whatever there is u. Alright, now this one is your final answer. Let's go to the second problem and see what we can do. The second problem is a little bit different from the first because we have another function outside the brackets. So we still can identify our derivative in the integrand, and this one will be 2x squared plus 1. So let's say u will be 2x squared plus 1, and then du over dx will be 4x. Alright, so dx is going to be du out of 4x. Now we can take the whole function here and then substitute u where there is 2x squared plus 1. So it's going to be 4x, and then 2x squared plus 1 is just going to be u raised to the power 4 du out of 4x. Now you can recognize at this point that this one and this one will go. Alright, and then you're going to have u raised to the power 4 du. Then at this point you can integrate, and when you integrate this you're going to get u raised to the power 5 out of 5 du, which is going to be since our u is 2x squared plus 1, is going to be 2x squared plus 1 raised to the power 5 out of 5 plus c. And this is pretty much it. We have solved the second problem. So you can follow the same technique to solve the third problem. Though the third problem looks quite intimidating, it's just the same thing. It's simple. Now let's solve the first problem. Now the third problem. Now in the third problem you have to also recognize the derivative. We can see that x raised to the power 3 plus x, when differentiated, can give you 3x squared plus 1, which is pretty good. So we are going to say u will be x raised to the power 3 plus 1 plus x, sorry, and then du out of dx is going to be 3x squared plus 1. The point here is to look for a way to cancel some things out so that your equation can be at least simple to integrate. Now that we have done this, we can say dx will be du out of 3x squared plus 1. Alright, so we take the whole function, which is 3x squared, the whole function here, plus 1 out of, and then we put u instead of x raised to the power 3 plus x. So we substitute u here, and then we multiply it by this, which is du out of 3x squared plus 1. Note that we are using the same technique that we have used in the first two problems. So now, as you can see, you can cancel out some stuff here. This and this one will go, and we're going to remain with 1 out of u under root du. All right, and it looks like we are approaching the answer. Thing u under root is just the same as u raised to the power 1 out of 2. So it's going to be 1 out of u raised to the power 1 out of 2 du. And this is the same as u raised to the power negative 1 out of 2 du. At this point, you can integrate. All right. So when you integrate this, it's going to be u raised to the power half positive a half, because you have added 1 to it, out of positive a half. All right, which is du. So what you need to do is to put the value of u, but first of all you have to simplify this because it looks ugly. What you will do is to say that u raised to the power a half, you divide it by 1 out of 2. So when you do reciprocal here, for you to multiply this stuff, it's going to be 2u raised to the power 1 out of 2. Now it looks beautiful. You can now put the value. You can now put the value of u, which we represented as x raised to the power 3 plus x. So it's going to be 2 x raised to the power 3 plus x raised to the power a half. And you know that u under root is just the same as u raised to the power half. That means x raised to the power 3 plus x raised to the power half is just the same as x raised to the power 3 plus x plus c. Now this is your final answer. Alright, thank you very much for watching. If you want me to solve more problems using this technique, let me know down in the comment. In the next video, I'm going to use the second technique of solving complex functions, of integrating complex functions, and we have 4 of them. We have done one, we are going to do the other 3.